Welcome to Topics and Statics. This time, simplification of a force couple system. So what the heck does that mean? Well, we've got some object, whatever this object may be, and there's a bunch of forces applied to this object. Could be a system made exclusively of forces. Some of these could be force couples, which means there's couple moments applied to it. And our goal is to take all these complicated things. There's a whole lot of forces involved, forces and couple moments involved. And I want to reduce them to one nice simple system that's easier to understand, but which has the same external effect in each case. In other words, it's going to produce the same total moment, it's going to produce the same total force. But I want to reduce this complicated applied situation to a simple applied situation. All right, here's another picture. All right, I've got some force applied to this object. I'm looking at the bottom left picture here. I have just a single force applied to this object. The problem is if I want to move that force over to point B, I can't do that because moving it over to point B changes the effect it has on the object. It would change the way it makes it rotate. It would change the way it wouldn't change the way it makes it translate. But so how can I move it over there? Right? I'm allowed to move a force along its line of action, but I can't just move it sideways somewhere. So this is equivalent to taking this force. I'm going to take the force, move it over to B, but in order to do that, I have to also subtract the force at B. So I'm adding 0. However, now I look at it slightly different. Instead of thinking of the two forces that are back to back, adding to 0, I can think of these other two forces. Let's pick these two forces. These two forces as a couple moment. So then what started off as a single force over here on the left, on the right-hand picture, I get a force now moved over to point B in a couple moment. So these are the types of games we're going to be playing. We're going to take one system and replace it with another equivalent system. And it's equivalent because it produces the same external effect. All right, here's another picture. Just what you wanted, another picture. When I got a whole bunch of forces in couple moments acting on a body, you can move each force and its associated couple moment to a common point O. So I've got all these forces in the left-hand picture. Just in this picture, it's only two forces. I calculate their moments about point O. When I do that, I can move those forces to point O. But now I've got three forces. I've got an applied couple moment in the left-hand picture, plus those two calculated moments. I add up all the forces as vectors. I add up all the moments as vectors. And in the right-hand picture, what I get is what I call the force resultant and the moment resultant. So in the 2D case, here we've got some forces acting on this beam. All right, I've got to worry about how to connect this beam over here at point O. It's got two traffic lights hanging on it. So each of those traffic lights has some weight. I can add those two forces to get a resultant force, right? The resultant weight, which I apply over there at point O. But then I also have to calculate what's the moment of each of those forces about O and add that in also. I can further simplify it. If the resultant force and the resultant moment at the end, I end up with a single force and a single moment. If those two things are perpendicular to each other, then I can further reduce that by moving that single force some perpendicular distance d to produce that same moment. Because of the condition, the resultant force and the resultant moment being perpendicular, we need to examine three different cases: concurrent, coplanar, and parallel force systems. Right? If there's a concurrent force system, what that means is all these forces are concurrent at a single point. The line of action of every one of these forces passes through a single point. In that case, those forces produce no moment about that point. As a result, I can take all those forces and replace them with a single force located at that point, only at that point. If I try and put it at some other point, I'd have a moment involved. Coplanar force system. So here all the forces lie in a plane. What does that tell me about the moments? All the moments are perpendicular to that plane. Right? That means they're into or out of the page. The thing's either going to rotate clockwise or counterclockwise. So the resultant force is going to be perpendicular to the resultant moment. It has to be. So I can produce that. The middle picture shows the resultant force and the resultant moment located at O, because that's what I calculated a moment about O. But now I can get rid of that moment by moving this force some distance d, perpendicular distance, such that it produces that moment. So now all I've got is a single force at the end. If I have a parallel force system, right, the system of parallel forces, and it doesn't add up to zero, the moment produced by each force lies along a moment axis A. Because the resultant force and moment are perpendicular, the force can be moved along a line that's perpendicular to both the moment and the force and the moment axis to a point which reproduces the moment. So again, I can move it over to some specific point and get that rotation. And the last thing I can do is what's called reduction to a wrench. And this is just putting everything together. I add up all the forces, so I get a resultant force. I calculated all the moments and found the moment about some point O. So I applied this resultant moment and the resultant force at O. But then I can take that force and break that force up into, I take that resultant moment and I break that moment up into two parts. One that's parallel to the resultant force and one that's perpendicular to the resultant force. And I can eliminate the part of the perpendicular component by moving that force to some other location, and then the only thing I have left are a force and a moment that are parallel to each other. That's called a wrench or a screw, and that's the simplest general force and couple moment system I can have acting on an object. I know all of that is very complicated. We went through it very fast. We'll work problems in class and you'll get a better idea. My best advice to you would be jump in, try the problems, see what happens.